Good afternoon, everyone. For case study 1, we are investigating whether the average body mass index or BMI of university students exceeds the healthy BMI level of 24.9. So this study is important because healthcare professionals have become increasingly concerned about unhealthy lifestyle habits among students, such as poor eating habits and lack of physical activity. So these factors can contribute to higher BMI levels, which may increase the risk of obesity and also the other related health-related issues. So to examine this issue, a healthcare center randomly selected 29 university students and recorded their BMI readings. So the collected BMI values are shown in the table on the right. Our objective is to determine, using statistical hypothesis testing, whether the average BMI of these students is significantly higher than the healthy BMI benchmark of 24.9. So for the step 1, gathering information. So first we will gather the necessary information from the case study. So the sample size is 29 students, which is considered a small sample because it is less than 30. Then since the population standard deviation is unknown and also the sample size is small, we will use a one sample t-test. So for the significance level is set at 5% or alpha equals 0.05, which corresponds to a 95% confidence level. So for the population mean specified in the problem is 24.9, which represents the healthy BMI level. So for the step 2, stating the hypothesis. So next we formulate the hypothesis. The null hypothesis states that the population mean BMI is at least 24.9. So the alternative hypothesis states that the population mean BMI is less than 24.9. So let's move on to the step 3, calculating the sample mean and also the standard deviation. So after stating the hypothesis, we calculate the sample mean and also the sample standard deviation. So to find the sample mean, we add all 29 BMI values and also divided by the total 29 values. So therefore the sample mean is 683 divided by 29, which gives us 23.55. So next we will calculate the sample standard deviation. So first we find the difference between each BMI value and also the sample mean. We square each difference and sum up them together. So the sum of squared deviations is 653.77. So using the sample standard deviation formula, we obtain a standard deviation of 4.83. So these values will be used in the hypothesis test calculation. So next we calculate the t-test statistic. So we use the formula where the sample mean minus the hypothesized mean is divided by the sample standard deviation over the square root of the sample size. By substituting the values, the sample mean is 23.55. So the hypothesized mean is 24.9, the standard deviation is 4.83 and the sample size is 29. So after doing all the calculation, the t-statistic is approximately negative 1.50. So to determine the critical value, the degrees of freedom are calculated as n-1, which is 28. So using the t-distribution table for a left tail test at a significance level of 0.05 and 28 degrees of freedom, the critical value is negative 1.701. So for the decision making, we compare the calculated t-statistic with the critical value. So our calculated t-value is negative 1.5 while the critical value is negative 1.701. Since negative 1.50 is greater than the negative 1.701, the test statistic does not fall within the rejection region. So therefore, we fail to reject the null hypothesis. So in conclusion, there is insufficient statistical evidence at the 5% significance level to conclude that the average BMI of university students is lower than 24.9. Therefore, we cannot say that the student's average BMI is significantly below the healthy BMI benchmark. Based on the sample data collected, the average BMI does not differ significantly from the healthy BMI level of 24.9. So that's all for the case study 1. Thank you.
Hi, Assalamualaikum and good morning everyone. Today I will present the solution for this hypothesis testing question using well t-test. First, we identify all the information given in the question. The sample size for female student N is 15 and the sample size for male student N2 is 14. The population variance for both group is unknown. The samples are also independent samples. Since the population variance are unknown and not assumed equal, well t-test is used. Next, we state the hypothesis. The null hypothesis, HO, states that the mean BMI of female student is equal to the mean BMI of male students. Meanwhile, the alternative hypothesis, H1, states that the mean BMI of female students is not equal to the mean BMI of male students. This is a two-tail test because we are testing whether there is any differences between the two means, where mean 1 means BMI of female student and mean 2 means BMI of male students. Next, we have to calculate sample mean, sample variance and standard deviation. First, we calculate the sample mean for female students using the sample mean formula. We have to add all the BMI values together. The mean BMI for female student is 23.25. Next, we calculate the sample variance variance using the formula. From the table, the total value 390.46 divided by 14 equals to 27.89. So the variance for female student is 27.89. Then we calculate the standard deviation. The standard deviation for female student is 5.28. Next, we calculate the sample mean for male students. Same like female, we added all the BMI value together, then we divided 14. So 329.91 divided 14 equals to 23.50. So the mean BMI for male student is 23.50. Next, we calculate the variance. When all the variance calculated, for the male student is 22.54. Then we calculate the standard deviation. Square root 22.54 equals to 4.75. So the standard deviation 4.75. After that, we have to calculate the test statistic. So we calculate the t-test statistic using the formula. So we have to substitute all the values into the formula. The calculated t-test statistic is negative 0.13. For the next part, we have to calculate the degree of freedom using the well-started weight formula. So we have to substitute all the values and the degree of freedom is approximately 26. Next, we determine the critical value. The significance level is alpha equals to 0.05. Since this is a two-tail test, alpha is divided into two tails. Using the t-distribution table with degree of freedom equal to 26, the critical value obtained is plus and minus 2.052. This means the rejection region is less than negative 2.052 or greater than positive 2.052. Since the calculated t-values lies within the acceptance region, we fail to reject the null hypothesis. In conclusion, there is insufficient evidence to show a significant difference between the mean BMI of female students and male students. We conclude that the mean BMI for both groups is statistically similar at the 5% significance level. That's all from me. Thank you. Assalamualaikum.